Hello all, welcome to GNB classes. In this class we are going to discuss about the solve problems based on my previous two classes. So those who have not seen my previous classes, link has been given in the description box. Please check it first. Questions are picked from Arihant book Algebra by Dr. S.K. Goel. These questions are from exercise for session 5. Question number 3 till 11 are the questions which we can do right with the knowledge that we have gained in the previous two classes. So here I will be solving question number 3 till 11 of exercise for session 5. Okay. In question number 3 we have been said that if a1, a2, a3 till an plus 1 be n plus 1 different prime numbers, then the number of different factors other than 1 of this number which has been expressed as a product of their respective primes is, and the four options are given to us. Okay. Now I have not written the options here. You can check it from your book itself. So it's a pretty straightforward questions. They have asked you how many number of different factors or divisors are there other than 1. So total number of divisors, total number of factors or divisors will be equals to m plus 1, 1 plus 1, 1 plus 1 till 1 plus 1 for the last prime. Now, there are 1 plus 1 is 2 and this 2 is repeated for n times because from a2 to an plus 1 there are n primes. So, the total number of factors or divisors will be m plus 1 into 2 to the power n. Okay, but they have asked you to find out the number of divisors excluding 1. Therefore, the total number of factors or divisors will be m plus 1 into 2 to the power n minus 1. Hence, option D is correct. Okay. Now, let us take question number 4. In question number 4, they have said, find the number of proper factors of 2400. Okay. Proper factors. So, if we go for prime factorization of 2400, we are going to have 2 to the power 5 into 3 into 5 square. Okay. Now, what are the total number of factors? It will be 5 plus 1, 1 plus 1, 2 plus 1. So, 6 into 2 into 3, that is 36. Okay. But they have asked you for proper factors. Proper factors means because this total number of divisors include 1 and the number itself. So if they asked you to find out the number of proper factors, then you have to subtract 2. That is, you have to subtract 1 and the number itself. So the total number of proper factors will be 34. Hence option A is correct. Okay. Now see question number 5. Again, it's a straightforward question. The sum of the divisors 2 to the power 5 into 3 to the power 4 into 5 square. You have to find out the sum of the divisors. Okay. So what will be the answer? Straight away I am applying the formula. So we are having 2 to the power 6 minus 1 divided by 2 minus 1 into 3 to the power 5 minus 1 by 3 minus 1 into 5 to the power 3 minus 1 divided by 5 minus 1. This is the sum of all the divisors of the given number whose prime factorization is given by this. Right? So let me just calculate this. What we are going to have. This is 63 into 121 into 31. But if you see the options, they have not given the answer as direct multiplication of this 3. They have written as a product of primes. So let me just convert this thing in product of primes. So 63 can be written as 3 into 21. 121 can be written as 11 square into 31. So again 21 can be written as 7 into 3. So it will be 3 square into 7 into 11 square into 31. Is it clear? Our option B is correct. Is it clear? Now let us come for question number 6. They have asked you, find the number of proper divisors of 2 to the power p into 6 to the power q into 21 to the power r for all p, q, r belongs to natural number. Okay? Again, it's a straightforward question, but here we cannot apply the formula for finding out the proper divisors because here these numbers are not all primes. So you have to convert this in primes. So what we will do? 6 to the power q can be written as 2 to the power q into 3 to the power q. 21 can be written as 3 to the power r into 7 to the power r. Therefore, 2 to the power p plus q, this will be 3 to the power q plus r, and this is 7 to the power r. Now it has been converted into primes. Now they have said to find out the number of proper divisors. So total number of divisors will be p plus q plus 1, q plus r plus 1 and r plus 1. This is the total number of divisors. Now the proper divisors will be two factors will be subtracted from this total divisors, which are 1 and the number itself. So that gives us the proper divisor. Hence our option B is correct for question 6. Is it clear? Question number 7 says that find the number of odd proper divisors. Odd proper divisors. And it is given the prime factorization. It's not prime factorization basically. We have to convert this in prime factorization. Otherwise we cannot find out. So this is 3 to the power p into 6 to the power q into 15 to the power r. So we have to convert this in prime factorization. So it will be 3 to the power p into. So we are having 2 to the power q into 3 to the power p plus q plus r into 5 to the power r. Okay. Now we have to find out the number of odd proper divisors. Now, as I told you in my previous class, that if you want to find out the odd divisors, there should not be any 2 present. So, from the first set, we will only take the element 2 to the power 0. From the second set, there will be p plus q plus r plus 1 number of elements, because it will start from 3 to the power 0, then 3 to the power 1, and this goes on till 3 to the power p plus q plus r. So there will be p plus q plus r plus 1 number of elements in the second set. And in the third set, we are going to have r plus 1 number of elements. Now, since it is an odd divisor, so if I choose any one element from this set and from this set, because from here, it will be only 2 to the power 0, that is only 1 coming, because there will be no 2 present in the divisors that we are going to calculate. So that will give you the odd divisors. So here, the total number of ways which we can select elements from our set 2 is p plus q plus r plus 1. And from the third one, we are going to have r plus 1. And from the first set, we are going to have only one element, which is 2 to the power 0. So, total number of divisors which are odd are this one. Is it clear? But they have asked you to find out the proper divisors. Now, proper divisors means you have to eliminate the divisor 1 and the number itself. Here, 1 will come, but the number n will not come, because if I want to get the number n, then all we have to do is we have to multiply 2 to the power q into 3 to the power p plus q plus r into 5 to the power r. But we are not going to have any factors 2 in the odd divisors, so we are not going to get the original number back. Therefore, since they have asked for finding out the number of divisors which are proper, so we will eliminate this number 1, which is already included in this number of divisors. Yes, and that is nothing but 2 to the power 0 when combined with 3 to the power 0 and 5 to the power 0, that gives you 1. So I have to eliminate that 1 to get the number of proper divisors. This is the total number of proper divisors which are odd. Hence your option D is correct. See question number 8. They have said find out the number of proper divisors of 1800. 1800 in its prime factorization will be 2 cube into 3 square into 5 square. Okay. Now we have to find out the proper divisors of 1800 which are divisible by 10. Which are divisible by 10. So, in the first set we are having 2 to the power 0, 2 to the power 1, 2 square, 2 cube. These are the elements. In the second set we are having 3 to the power 0, 3 to the power 1, 3 square, and in the third set we are having 5 to the power 0, 5 to the power 1 and 5 square. Now look at carefully. If you want to get the divisors or factors which are divisible by 10, it means what? That at least 1, 2 and 1, 5 must present in that factor. Okay? So if there is 5 and no 2, you will not get any factor which is divisible by 10, or the other way around. So in the divisor set, at least 1, 2 and 1, 5 must come. Is it clear? So from the first set, let us eliminate 2 to the power 0, because 1, 2 must present in my factors. Then only it will be divisible by 10, as I mentioned right now. So, and from the third set, we have to eliminate 5 to the power 0 at the same time. Why? Because if no 5 is present, because if I choose 5 to the power 0 means what? There is no 5. So that will not give you a factor which is divisible by 10. That is why I have eliminated 5 to the power 0 as well as 2 to the power 0. It means that whenever you are choosing a single element from this set and a single element from this set, then it will be definitely divisible by 10 whether any element from this set comes or not. Comes or not means if you take 3 to the power 0 even, then also the factor will be divisible by 10. Am I correct or not? So from the first set we are going to have 3 elements. From the second set we are going to have 3 elements. And from the third set we are going to have 2 elements. So total number of divisors which are all divisible by 10 will be 18. Is it clear? But now they have asked for finding out the proper divisor. When the numbers 1 and 1800 are subtracted from the total number of divisors, that gives us the proper divisor. Okay. Now 1 and 1800, out of these two, observe carefully, 1 is not included here. Why it is not included here? Because to get 1, we need 2 to the power 0, 3 to the power 0 and 5 to the power 0. That is not possible. But 1800 is possible. Why? Because when we have selected, because out of these 18 options, one option is there where 2 cube is multiplied with 3 square is multiplied with 5 square, which gives us 1800. So to get the total number of proper divisors which are divisible by 10, we have to subtract 1 from this. So the answer should be 17. But here the options which are given are 18, 27, 34 and 43. So I think there is a printing mistake. In my opinion, the options should be A, because A is 18 over here. But I don't know whether they have, maybe they have not considered the proper divisors, because one proper divisor is very much it is coming, which is nothing but your 1800. So which has to be subtracted to get the proper divisors which are divisible by 10. Hence, in my opinion, it should be option A, not 18, but the answer should be 17. Is it clear? Okay. Now let us move for question number 9. In question number 9, they have said that what is the total number of divisors of 480? 480 written in prime factorization like 2 to the power 5 into 3 into 5. So total number of divisors of 480 that are of the form of 4n plus 2. Okay, 4n plus 2 means if I take 2 common, it is 2n plus 1. So 1, 2, exactly 1, 2 must present in the divisor. then only it will be in the form of 4n plus 2. So, in the first set, we are having 2 to the power 0, 2 to the power 1, 2 squared, 2 cubed, 2 to the power 4, 2 to the power 5. But out of that, we are only going to choose 2 to the power 1, this element only. Okay, we will not choose the other elements. And in the second set, we are going to have 3 to the power 0, 3 to the power 1. And in the third set, we are going to have 5 to the power 0 and 5 to the power 1. Therefore, from this set, we will choose only one element, which is nothing but 2 to the power 1, that is 2. And from this set, two elements can come. Either of these two can come, and that can come in two different ways. From the third set also, two different elements can come. Okay, so total number of divisors which are in the form of 4n plus 2 are nothing but 4. Is it clear? Hence option C is correct. Question number 10 is same as your question number 9. They have said find the total number of divisors which are of the form 4n plus 2 of the number 2 to the power 5, 3 to the power 4, 5 to the power 10 and 7 to the power 6. The only difference is that in the previous question it has been said that n is greater than equals to 0, and in this case they have said that n is greater than equals to 1. Now for a time being, let us just forget about this. Let us assume that this is n is greater than equals to 0. The difference will be that here when n equals to 0, that divisors we will consider, but actual problem demands that you should not consider n equals to 0. That we will calculate later on. First, let us assume that n can be equals to 0 also. So in that case, what will be the total number of divisors which are of the form 4n plus 2? Again, 4n plus 2 means it is 2n plus 2. So 1, 2 should present. Exactly 1, 2 should present. So from this one, we will take only 2 to the power 0. That is, one element should come from that set. From this, again, 5 elements will come. From this, 11 elements will come. From this, 7 elements will come. Correct? So it is coming to what? 385. Is it clear? So there are 385 total number of divisors which are of the form 4n plus 2, but in that case you are considering n is greater than equals to 0. That exact sum we have done in the previous one. Okay? The only difference was that the digits were different. That's a separate issue altogether, but the problem structure was same. But in this question they have said that n is starting from greater than equals to 1. Now look at carefully. If n is equals to 0, then what we are getting basically, if n is 0, the first digit which is of the form 4n plus 2 will be 2. Yes or no? Because if n is 0, it will be 4 into 0 plus 2. So the first digit will be 2. Okay? 2 is a factor of the natural number n which is of the form 4n plus 2. Now, how this 2 is coming? Look it carefully. It is actually from the first set we are taking 2 to the power 1. From the second set we will consider 3 to the power 0. From the third set we will consider 5 to the power 0. And from the fourth set we will consider 7 to the power 0. Now that factor will be 2 to the power 1 into 3 to the power 0 into 5 to the power 0 into 7 to the power 0. That will give you the factor 2, which is of the form 4n plus 2. But in this case, this particular case has to be eliminated. This particular case should be eliminated from the total number of divisors. Are you getting my point? Because in that case, when n starts from 1, the first factor that you are getting of the form 4n plus 2 is not 2. Rather, it will be 6. Because when n is 1, the first factor of form 4n plus 2 will give you what? 4 into 1 plus 2, which is 6. Is it clear? It will not start from 2. Rather, it will start from 6. Okay? Therefore, the total number of divisors which are of the form 4n plus 2, but when n is greater than equals to 1, the total number of factors will be 385 minus 1, which will give you 384. Hence, option C will be correct in this sum. Is it clear? Have you understood why I have subtracted this one? Because this term will not come, which is 2 to the power 1 into 3 to the power 0 into 5 to the power 0 into 7 to the power 0, which we have already considered in the previous sum. Because there, your n was starting from 0 onwards. And in this problem, n is starting from 1 onwards. Is it clear? Okay. Now let us move for question number 11. So this question. They have said that total number of divisors of n 3 to the power 5, 5 to the power 7, 7 to the power 9, which are of the form of 4n plus 1, where n is greater than equals to 0. Okay? Now, any number you can dream of can be either of four forms. Either it can be 4n, or it can be 4n plus 1, or it can be 4n plus 2, or it can be 4n plus 3. There is no integer which is other than these four forms. That's for sure. Okay? Now, 4n and 4n plus 2, these two are even numbers. Now, under any circumstances, by taking any digits in any number of times, the divisors that you will get for n will be neither of the form 4n, nor it will be in the form of 4n plus 2. Yes or no? Because whatever divisor, because to get 4n and 4n plus 2, it must be an even one, and to get an even divisor, we must need a 2. But in this prime factorization, there is no 2. So there is no question of getting divisors of the form 4n or 4n plus 2. Okay? Therefore, all the divisors that we are going to have will be either of the form 4n plus 1, or it can be of the form 4n plus 3. And if you find, you will see that the total number of factors or divisors are even. The total number of divisors are even. Therefore, the divisors which are of the form 4n plus 1 will be half of this. So it will be 480 divided by 2, which is nothing but 240. Is it clear? If the question would have been, find out different factors which are of the form 4n plus 3 in this question, in that case also the total number of divisors which are in the form of 4n plus 3 will be 240 again. Okay? So for this question, the divisors which are of the form 4n plus 1 will be 240, hence option D is correct. Is it clear? So that's all for this video. If you like my class, do hit the like button and subscribe. Click the bell icon to get notified about my new uploaded videos. Put your queries and doubts in the comment section. You can now reach out to me at my mail, my Facebook page, my Instagram. You can also join my WhatsApp group for doubt clearing. Link given in the description. See you in my next video. Till then, goodbye and take care.